Okay, so good afternoon, everybody. New antennas for new space. So here is what I have to talk about. I'm Pascal Dagras from Anywave, a startup company that develops and manufactures new antenna for space constellations. And today I'm going to introduce in the pitch new antennas that don't even look like antennas, actually. So first of all, what are the challenges we have to tackle? That one. If we want to manufacture antennas for space constellations, they have to be compact, first of all. Because satellites are compact. Maybe not as compact as cornflakes, but very compact nonetheless, and so should be antennas. They have to be industrialized. 900 satellites a year, 4 platform antennas on each satellites. That's a lot of satellites. And we want to manufacture antennas in tenths and hundreds of units, which requires an industrial approach from the very beginning of the design. And last, but also first, we need performance and robustness. Because the services that our customers deliver, they cannot get a compromise on performance and robustness. Antenna is a single point of failure on satellites, so we require quality. So what we've done in Anywave for the last 3 years, because we're a 3-year company. With a catalog of 3 component on-the-shelf antenna that are platform antennas, so S-band, X-band, GNSS all bands, GNSS that has been developed thanks to the support of ESA. Thank you, ESA. And we are very proud to have space heritage on the 2 first antenna, on Angels and ISAT satellite, and we've sold 39 antennas in 2019. We are very proud of that because that's a performance for a company that is not yet 3 years old. So this is for today, and for the tomorrow, if we want to go further with this catalog, here we have the secret sauce. The secret sauce is this piece of ceramic that is a 3D lattice ceramic antenna, 3D printed. This is a breakthrough patented technology that combines 3D printing with this ceramic material with top-level, state-of-the-art electromagnetic engineering. And we combine these 2 technologies to make this masterpiece of technology. And why do we think that this masterpiece of technology is relevant to manufacture antennas for CubeSat, for new space, for satellite constellations? Well, again, the same 3 criteria that I mentioned before. Performance and robustness. Ceramic is a very precious material that has been used for planes, for dishes, for dentistry even, because it's very solid material. And if ceramic can make it in your mouth, well, it can make it in space, I think. Because your mouth is a very harsh environment, and so is space. This might be a joke, but actually it's not. We've manufactured first batch of 8 ceramic antennas last year, and we've qualified them using the most complete tests, thermal, vibration, shocks that we could use, and it passed the test. So it's very solid and it's great for performances. Then it's compact, because we can structure the material with these lattices that you can see. And these lattices that you will see on this patch, if you want, is inspired by nature. It's inspired by crystallography. We use the same lattices as crystallography, and we can change the lattice to get the best performances out of the material and to get the most compact design. So that's great. And then industrializations, because we want to manufacture tens or hundreds of antennas. And 3D printing, ceramics 3D printing, is a manufacturing process that suits the manufacturing of tens or hundreds of antenna. So we believe it's great, and it's on the top of the number, it makes it possible to adjust the lattice, to adjust the performance, the wavelengths, so to change the antenna we want to manufacture. So here we are at Anywave. So we have the secret sauce, we have the technology, we have a brilliant and enthusiastic team of 16 people, and we have one ambition, becoming a leader on the market of new antennas for new space.
This was actually a smart move. Taking away my microphone created a pretty charismatic speech. Yeah, lovely to hear. Now that I got my microphone back, any questions for the walking mic? Yes. Monsieur Fonseca.
Can you explain what role the porosity of the ceramic plays in the performance of the antenna, and if this is important?
So the role it plays, I don't have the anymore. First of all, there are the electromagnetic properties of ceramic. Ceramic has a great epsilon air, which is, when you take the bulk material, it is higher than 20. And when we structure the lattice, the 3D lattice, we can change the epsilon air.
Okay.
And for the RF men, we have in Anywaves. They are engineers, doctors, but they are also artists, I would say. And if you give them new colors, with this new possibility to adjust the epsilon air thanks to the lattice, well, then they can paint masterpieces of art, because you have new possibility to design antenna, changing the epsilon air of ceramic.
So you're basically building the architecture of the morphologic structure by managing the lattice structure.
You change the electromagnetic properties with that.
Thank you.
Okay, thank you. If there is no super pressing question, we will press on, because basically we are... Oh, one critical question over there, the gentleman in second row.
Hello. Are there frequency restrictions on your antennas?
So I won't be brave and I won't answer the question. Frequency, intrinsically, no. Then it depends on the size of the antenna as well. So with the epsilon air, we can get, thanks to ceramic, we can get more compact design, because epsilon air is high. The higher epsilon air is, the higher is the wavelength of the electromagnetic wave that you can receive with your antennas. So we can be more compact, but then it depends on the size you want for your antennas. And with this technology, actually, we mostly focus on antennas that are 1U size, because it is industrially aligned with what our customers expect.
Great. Okay, one more question. We will run over time slightly, but I will take the blame, because questions are actually more important than answers. So yes.
Thank you. Thanks. I imagine this is one beam. The radiation pattern of the antenna is a single beam. Do you imagine that this could be put in an array to make beam ranging, beam control, things like this? Thank you.
Yes, I can imagine it. Yes, definitely. But we have to then we have to manage the design of the antenna. This is a very simple structure, but it's a square, basically a square. But everything's possible. We can take any other design using this 3D printed material, so it makes it possible to design beams or open antennas, whatever.
So it's the circled square, squaring the circle. I like it. My jokes don't work on stage. They work on a personal level, but not on stage. You know, squaring the circle kind of is cool, and you can do anything with it. I like this approach. The pitch was lovely. Thank you so much. We got 2 startups to go.